Good evening. Is it audible? You can message. I can check it out. Or any thumb. Screen is visible. Is it audible? Yes. Okay. Thank you. Next, we have there are two concepts are left out. We told to okay to the class. So we have there's one important concept called Huffman algorithm. That Huffman algorithm it's come under design of analysis of the algorithm. It's like a Prim's and Kruskal algorithm same way. So but you need to cover that syllabus. We have a one more algorithm. So what this algorithm will be says we have a long set of inputs are there. I want to convert it into decoding that messages and how to do the representation of the message. You will get an only general to explain Hoffman algorithm or the Hoffman concept for that one. So we wish to encode the messages with as long as the bit, the string, by using assigning either 0 or 1. And how to assigning 0 or 1 bit for each and every symbol. There are n symbols are there. For that each symbol, I have to decode it with zeros and 1. The zeros are always will be assigning for the left side and right side will always assigning for that 1 to assign for 0 and 1 depending upon the length of the string, then I can construct the Hoffman tree. In the exam or in will get it to construct the Hoffman tree or explain the Hoffman algorithm. So what will happen? Say for example, I have a this is my message. Say A B A C C D A. For this can be encoded by using this symbol. Say A can be assume what will be happen. Number of the length of each input has to be more than that character. So what way the in output message will be get it encoded. For example, A is also 0 1 0. B all are of length 3. So whenever all the inputs A B C D inputs are there, all the inputs are of length 3 3 3. So I can get it encoded messages like this. What is an encoded message? Wherever I have A can be replacing with 0 1 0. See, this is a 0 1 0. So what about B? B can be represented by 1 0 0. That is a B 1 0 0. What is the C? Next is A again. A can be encoded with 0 1 0. The same way, what complete message has been encoded by using this. So this is what Hoffman algorithm say. Whatever I have a symbol that will be encoded by either 0 or 1, that can be message converted into terms of binary value. But this encoding method, whenever I'm using these three codes or assigning is inefficient. The 3 bits are using, so 21 bits are needed to encode the entire message of this length. Instead of doing that, can I take A, B, C, D with the length of 2? Assume I'm taking some number 0 0 0 1 1 0 1 1. So what happened? Then the code message would be instead of 21 bits, it will be getting down these bits. Same A represented 0 0, B will be represented 0 1 like that encoded. So now I got a 14 bits of that. See, we wish to minimize, still I want to go to minimize the length of that. Is it possible? Then we go for applying for that, re-examining that same code in a different way. Then what's the different way? Instead of doing the two, what will happen? Each of the letter, for example, you had to take that input A, B, A, C, C, D. We are considering about how many occurrence of that letter. See, that will be taken into part of decoding the code. It is zeros and one. See, how many times A will be occurring 2 times, B will be occurring 1 time, the A will occurring 3 times, B and D will be occurring 1 time, and C will be occurring 2 times. So, depending upon that, I need to write a code about that. B has to be 1, C, D has to be 1, A will be 3, and C. So, each letter B and D appear only once in the messages, whereas letter A has 3 appear. That has to be taken into consideration for while decoding that messages as the length of that one. If a code is chosen that letter A is assigned a shorter bit string than the letter B and D, the length of the encoded message would be small. So what happens? So now I am taking A has to be get 0, whatever the 3 times occurs, A has to be get 0 and B has to be get 0 1 0 and C has to be get 1 0 D. See, that will be taken on random. See how this will be getting in that one, how many number of times will we get it, we can take it. So you are randomly, I am applying for that one, then what will be get it? So because the We have ABA encoded with which we requires only 3. See again, this is long messages. It is unsuppressed. In some random fashion, I go it. So that is also not getting for that. So what we have to do, the codes are not constructed on the basis of the frequency of character. See, this is not taken the frequency of the character. See, long occurrence we taken 0. Small occurrence we take the long number of times 3. See, A is 3 times, but A will be taken as 0. B will be only 1 time, but it will be taken 3. See, this is also not good way of representation. So, what will we do? See, that can be rewrite by using the occurrence of the symbol to construct. See, the frequency within the whole set message, the same code will be for used for each messages. For that, we need to constructing a binary tree by using the values of the occurrence of that letter. See, that we called as an Hoffman algorithm. So what's your Hoffman algorithm? Let me assume this is my Hoffman tree. See, this Hoffman tree will be constructed depends upon the number of occurrence. See, what is the occurrence? We already told B will be according to these messages. A will be, B will be occurring, D will be occurring only one time. So that's why I start with B will be occurring only one time, B and D. See, B is first, D is right, then 1 and 1 will be representing how many of number of times it's occurring that one. I'm representing B and D. See, after that, you do the combination. What is the parent of that? I'm getting BD. The BD value is 1 and 1 is 2. So what the next number is C. C is occurring in how many times? The C is occurring in 2 times. Then have to write the C. Then you can write C. C has to be occurring 2 times. Then you can write CBD. Combination of this child and this child, you can write CBD. I got a 4. Then A is occurring how many times? 3 times are occurring. You can take A. A will be occurring 3 times. According to that, you can write ACBD of 7. ACBD 4. See, I got this one. See, this is what, depending upon the occurrence of those symbols, I am constructing a Hoffman code, or that is Hoffman tree. So, this tree says that Hoffman algorithm is working. So, in how to write the frequency of that, see, I am telling what Hoffman tree will be says. I have to assign 0 and 1 for this tree. See, the root will be start. The left side is always 0. Right side is always 1. Again, left side is always 0. Right side is 1. Left side is 0 and right side is 1. According to that, let me take. See, left side is A. A value is 0. Then what is the value of that one? This is that with respect to that Hoffman tree construction, I am getting this code. A will be 0 because the left side. So let me go. B is what? 110. How 110 is coming? Where is the B? Here. Right side is 1. Again, right side is 1. Left side is what? 0. 1, 1, 0. So then we can construct this B in this position. How to know about the position? This is the position. So what about C? The C value is 1, 0. What is the meaning of 1, 0? Right side is 1 and left side is 0. Then what is the position of C? C. You can ask, why madam written the C here? Why can't write that side? Because that depends upon what is the question is given in the paper. The frequency code is also given. You need to construct only the Hoffman tree of that one. So that can be constructed using of this method. So you can construct this. Then what is the given? D will be given. D is 111. So using D is 111, always write it. So D is 1, D is 1, D is 1. This is the D has to be get 111. See, that is the Hoffman tree will be constructed using the concept of 0 and 1. See, this is the tree I am constructed. So this is the frequency symbols and the frequency of the occurrence and what is the code. So what is the frequency of occurring? How many times that symbol A is presented? B is 6 times. This is the code. C is 7 per time. This is the code. So this is the table is provided. This table, how to construct a Hoffman tree. In the exam, you can write explain Hoffman algorithm or with an example. You can take any example and any number of frequency and any number of code you can write. So whatever you write the code, according to that, you need to construct the tree. Or whatever you construct a tree, according to that, you need to write a code. So that both are has to be balanced together. See, for example, A is 15, 1, 1, 1. How to construct? First, always choose the lowest number among this frequency. So while constructing, what are the lowest numbers? We get 6 and 7. See, we have a lowest number is 4 is there, but what is the 4 level? 0, 1, 0, 0, 1. So where to construct 0? It starts from the root. The first left is 0. Next we go for the right is 1. Again right, left is 0. Again left is 0. Again right is 1. Observe everyone. F is 4. I am writing this position. F is equal to 4. Okay. Then what is the lowest is 1. H is 1 lowest. The H lowest is be 1. So what is the number is 0, 1, 0, 0. Then you can start from 0 is left. Right is 1. Then we have all our 0. 3 levels of 0. Each level will be assigned number. 1 level, second level, third level. Thus, I got H is equal to 1, F is equal to 4. H is equal to 1, F is equal to 4. Then I got, this is the position. See, this is the lowest number I am taking. H and F and 4, I got 5. See, after 5, what the next number I got? 6 should be there. So, the 6 is, I need to write 5 greater than that 6. Then I should be right in the right hand side of that one. Then this is the position for the B I am writing. You add together, then I got 11. H, F, B is the 11. So, okay, the next we need to go for who is the next number. Then I can't write. We have a, again 6 and 7 is there. I need to write in this position 6 and 7 because it have a 6 is there. Okay, then I need to, because the 6 number is 110, so it is in the right position. 1100. According to that, it will come to this position. And 7 is 1101. 110. So you need to consider. So overall, the Huffman algorithm, it says, so you need to construct binary tree by using the method for the alphabet, using the frequency table. See, that tree is called as an Huffman's tree. What do you call? Binary tree constructed and the method of alphabets, because that we have a number is also there and frequency is also there. Using that, we need to constructing that we call as an Huffman tree. Huffman trees are constructed. The code of any symbol in the alphabet can be constructed by starting at the leaf node, representing the symbol and climbing up towards root. The code is initialized to null each time the left branch tree is what? Climbing up. 0 is appending at the beginning of the code. Each time that the right branch is climbed out, it will called as a 1. Appended at the beginning of the code. This is the method. Left is 0, right is 1. Towards we're climbing up about the root. See that we are using in the Huffman algorithm will be assigning 0 and 1. The information portion of the tree contains the frequency of the occurrence in that center. That A, B, comma 1. That is a symbol is represented in that one. A set of root nodes are used to keep track of pointer for the roots for the binary tree, either in the left or right tree. Whenever you want to insert a new node into the tree, we have to call PQ insert, the pointer of the priority queue, and we are to use the minimum delete to remove any pointer of the node with the smallest information from those priority queue. We have to use PG min delete. If in case asked, then how to write for the Huffman algorithm? You can start with the construction of the root node with the empty priority queue. It should go in the ascending order priority queue. I have to first construct make a tree using the frequency of table. I am creating the leaf node with because starting from the leaf node for the position it is started. Again, I start inserting my every leaf node into the root nodes. So the continuously should be go to the at the end of the root node. You can calling about that adding the node into the root node, or you can delete the node. There are two functions are going. PG mean delete, or we can call for the pitch, because one for the left node, one for the right node. Because of 2 times I can delete. Or if you want to combine both the branches into single tree, you can create a make tree of information of 1 and 2. B1 no, D1 no, 1 plus 1 what? 2. I'm combining these 1 and 2. We are creating a making tree. After that, I have to set what is the left, what is the right. Set left and set right. Set left is P1, set right is P2. This loop has to be continued till towards the finalization of the root. See, this is what Huffman algorithm. If you want to easy to understand Huffman algorithm, the main 3 concepts are using, frequency counts are using, implemented can be by using the priority queue, and tree construction with the remove two nodes with the lowest frequency and create a new internal node with the two nodes as a children frequency equal to the sum of their frequency, and can insert a new node back to your priority queue. And code assignment can be done by using left edges are 0 and right edges are 1. So in overall, what I told till now from the 10 minutes, that has to be recapitulation in these two slides. Easy to understand. So what is an Huffman algorithm? If we need to prepare these two, what is that exactly the points? And you can take one example and you can elaborate your answer. So this is the one concept will be left out. See, apart from that, we have a one more concept. See, that is called threaded binary tree. What is threaded binary tree? See, for example, I have this tree. So whenever I want to implement this tree, this is also very, very important. You will get an exam. Explain threaded binary tree or right side threaded binary tree or left side threaded binary tree. It's nothing, not any problem. Just is a concept. So what is the threaded binary tree? See, whenever I have take this one, see, whenever I'm implementing by using linked list, see, this is my D. I haven't write, when I'm writing linked list of that, then by through the W linked list, we have a left side is also null, right side is also null because there is no pointer at all. Only the information is D. Again E, again left side is also null, right side is also null because there is no left and right. See this. So whenever I am implementing the normal binary tree by using the linked list, so what will happen? More number of null pointers should be available. More number of null pointers should be available. So to avoid how many number of nodes are there, that to plus one number of null pointer will be getting for that one. So 2 plus 2, 4, pro 4 plus 2, 6. How many nodes are there? I have only 5 nodes, but number of null nodes are, see, more than that. Null node or null pointer, or we'll get a links. See, that we call, how can we avoid that? So whenever when I concept the linked list, I need a memory. The memory will be used for storing for left address, right address, as well as the information. Then simply unnecessary, I am using the memory to store the null pointer. See, that leads to a problem with respect to the memory. To avoid those concepts, instead of I am storing this D in two null pointer, can I give this D address? This is the null address to store as a value. Should we go back to the left side? What is the left side? I don't have any left side. Then D has to be pointed to A only. And if you have a left side, immediately I can give. See, what about right side? Right side is also not there. Then right side will be given pointer to B only. I have a two pointer. D is also null, the left and right. D will be given predecessor to the root, and right side of the D null pointer I am given to that the successor of that one, the in order processor. So what is the in order processor of this? It should be go to B. When I come to E left side is B. I have to give a pointer to this. So what about right side? The right side I am giving in order of what? A. See, like that, I am changing my null pointer. Instead of with I am representing null, I can give either predecessor value or you can give successor. That can be overcome. That's the overall concept is that only. Threaded binary tree, I am constructed to avoid the null pointer by using the concept of the threads. Threads are the useful links. I can go with the in-order tree processor. With that you are using either a predecessor or successor concept. See, binary tree have too many null pointer. N number of nodes, we have a n plus 1 null pointer. Replacing all those null pointer with useful threads. See, this is threaded binary tree is the normal binary tree, but we are not using to travels for any stacker recursion. I'm not taking any stacker recursion because we already know how to implementing stack and recursion. So in decrease the memory wastage to setting of all the null pointer of a leaf node, we are using in order predecessor or in order successor. Only this means answer. Define binary tree, that is very important. We are to decrease the wastage of memory. We are using in order predecessor or in order successor. Then will be there is no in order predecessor or there is no successor. Then always that link will be pointing to what? root node that always will be pointing to the root node. The idea of threaded binary tree to in-order traversal of our binary tree without using any extra space. So if we are using in the hardware, it will not take too much of spacing or efficiency will also better weight in that hardware. So what is the advantage? It enables the linear traversal of the elements. It eliminates the use of the stack. It performs the linear traversal to save the memory. And it is also enables to find a parent node without explicit use of parent pointer. Or threaded tree will give forward and backward traversal of any node in fashion. See that will how can we find a predecessor and successor is also very much important. So let me take this as an example. For this example, I am taking for this is the node and this is the predecessor. Predecessor of 25 is what 33 and successor of this has to be get node. So whenever I'm taking the predecessor, the one left and then right you can take as the predecessor and successor is the one step right side and the left you can has called as a successor of this node. So what the predecessor of this node has to get one step left and right you can choose. So what the successor of that node is one step right, then left we call as a successor because you are using successor and predecessor in the concept. See, whenever I need to construct a threaded binary tree, I should be use left side is null or right side is null. So there are two types of threaded binary tree. One we called left in threaded binary tree or right in threaded binary tree. So what is in threaded binary tree? We'll get the common question, will we get it? So replace it with all the pointer node would be visited before the predecessor. A pointer we call in order traversals that we replace all the null pointer or the null link with the in order predecessor. All are have only the in order predecessor pointer, then that type of tree we call the left in threaded binary tree. Are all the pointer with we have successor. So we have using the after visited the pointer in order traversals that we call as a right in threaded binary. What is that one? The left and right I can show you with that one. See this is that normal tree. See this normal tree I am writing in this normal tree. I have to write the threaded in the dotted line. See, I don't have any left for the H. Then I am taken as a root part of the left. This is the in threaded. See what is the right side of the H? The success, the immediate root node in order traversal. The H for this one D. So when I'm taking for I, who is the left? The left part is D only. Because of that, I am writing this. All the dotted lines are represented, we call as a thread. In the exam, you just write the binary tree. You can represent it in the dotted line for the representative thread. That is more than enough. So that's only represent. So this is dot is called in threaded and this is called right threaded. So this tree contain both in thread and right thread. That is left is also there, right is also there. See, this is the left side and this is the right side. So when come to E, who is the root for this E? B only left. So what the next one is? This is the root node. So when come to for a J, J have a left node is this is the root node. So whenever J have a right, see that right has to be get to go for the next right of that. So when I come to G, G left side is this and G right side is the next root level. Just I am giving the link through the dotted line we call as a threaded binary tree. So that's all I am representing in the same format how I am doing in that in order preprocessor. See that order we need to represent the threaded binary tree. See this will be contain both left thread, right thread, left child data, right child data, that the link I am representing the data of that one. Okay. So what is single threaded and double threaded? I already told. What is single threaded? If you have only one left side only or right side only, I don't have any other thread, then it is called single threaded. Or you have a both left side is also there, right side is also there. So then we call it the double threaded. So this is an example for the threaded both double-ended threaded tree. Serious where null right pointer is made to point in order successor. So then it is a single. Or if both left and right are null, we call in order successor or in order predecessor. See what is single thread? Assume now. See I have a diagram. See we are giving only that right side. See, always I am giving the right side I am giving. See, this is, I am not writing any, I am not giving one more thread to the 50 from this far. Okay, then we called as a right in threaded. This is an example for the right in threaded. Whenever right in threaded, we have then right pointer is threaded towards in order successor. It's a single threaded binary tree. So we have a left side is there, data is there, right side. Then I need to write only the right threaded part. If you have a right side, this is an example for the right threaded. See, always I am pointing the right sided. See, this is I am pointing the right threaded. So I am representing only in the right side. So this is the example for the right. So what is the double threaded? We have a both the pointer. See, int L thread, int right thread. See, assume I am giving this right thread. Again, I am giving to the left also. See, so I am giving both left and right threaded. I am giving. See, that is called. See, that tree have both left and right. See, I can construct it like that is called double-ended tree. See, this is we need to cover about. So, what do you mean by threaded binary tree? How to write the threaded binary tree? Concepts. So don't don't about the problems. All those nothing should be concentrated. Only the concentrate what is threaded binary tree, what are the types of threaded binary tree, how can we implement. So what are the disadvantage? Extra memory usage will can be avoided. And while in this threaded binary tree, any node insertion and deletion is very much complicated compared to the normal binary tree. We have another type, heterogeneous binary tree. I already explained, but you should be know about what is heterogeneous binary tree. It is a type of binary expressions it contain both operator as well as an operand. So this is called heterogeneous binary tree. It contains all the operators should be in that internal node, and operands will be contained the leaf node. See, all the operands will have a leaf node. This is also one type of binary tree. It is called as a heterogeneous binary tree. See, what is that one heterogeneous binary tree under contain? Heterogeneous binary tree can be represented by using the concept of that operator will be defined as 0, operand will be defined as a 1. See, then we have a union contain the character information. Character can be plus, minus, star, and number information. It can be integer or floating. So it contains both left pointer as well as the right pointer. See, this is the common question in all the question paper. How to evaluate your binary tree? If there is any operator should be there in the binary tree, so that can be evaluated by using evaluate binary tree function. So evaluate binary tree function, the middle you have a symbol and left side is an operand 1, right side you have a operand 2, operand 1 and operand 2 will be using. So this is an evaluation binary tree. Wherever I put an important, you need to concentrate. The evaluate binary tree will contain operand 1 and operand 2 with the symbol. If the tree of is equal to operand, let me check single operand, we check it out. So that will be taken the value. If you are called operator, I need to call the function for that evaluation of the binary tree to find all the left, and I need to find all the right side of that one. If it is equal, if the U type is equal to operator, then we'll check, find all the left side of evaluate again once again all the right side, again take the values of information, again call, do the operation of symbol operand 1, operand 2. So that only how I am computing for the operation files you need to complete. So this will complete your syllabus. What we have, it will be left out in the module 4. So the B. See, it will, just a minute. See, it will covers all the concepts. I think compared to the second internals, third internals will get very easy. Whatever I'm completed in the syllabus, so you need to concentrate all the topic. All the best for your internals. Do well. Question papers are very easy, and don't miss the quiz. Quizzes also will get easy scoring for about that. We are taking by the part of all the three internals averaged while finding about, and today is the last day to upload your assignment for both. Everyone need to be completed for your assignment work by 12 o'clock. So thank you all and good luck for your futures.